Grade 10s, if you've been enjoying doing names and formulas, then you'll probably enjoy continuing on with ionic names and formulas using polyatomic ions. So this section is optional for the grade 10 curriculum, but I really recommend that you learn how to do this, especially if you're looking at doing grade 11 chemistry, because we're going to use it all the time there. And really, it's not that hard. So polyatomic ions make ionic bond. It's got the word ion in it. The word poly means many, and atomic refers to atoms that are in that grouping together as a group. So we've got a group of atoms, a group of many atoms, and they're still an ion. They still have a charge. So we're going to treat them the same that we would any other ion, but because they're a group, I'm going to put them in a bubble. I'm going to put them in brackets. So polyatomic ions usually act like nonmetals. They usually take on a negative charge. They're usually going to attract electrons, but not always. Ammonium, which is an NH4 grouping with a +1 charge, actually acts more like a metal. But otherwise, either way we look at it, polyatomic ions are groups that come with a charge. And we're going to put those groups in brackets, and we're going to treat them the same way as anything else. The only difference that we're going to find is that they already have ion names, so we're never going to change their names. For regular ions, we change the name to "ide." We don't change these guys. Most of them end in "ate" or "ite." Hydroxide and cyanide end in "ide," but those are the only two exceptions. Everybody else already has an ion name, so whatever their name is, leave it like that. So let's take a good example. We're still going to do the symbols, the charges, the crisscross, and the reduce. Let's take a look at calcium and hydroxide. The symbol for calcium is Ca, and for hydroxide, OH. So the symbols are Ca and OH. You notice how I put the OH in brackets? I have to because it's a group. That reminds me that I can't change anything inside the brackets. The charges on calcium, it's a charge of +2. It's in group 2 in the periodic table. You'll find on a list of polyatomic ions that the charge on the hydroxide is -1. In grade 10, we'll always give you a list. In fact, and even in grade 11, I tend to give you a list to work from. But at some point, you just kind of have to learn the most common polyatomic ions and their charges. Now I've got the symbols and their charges. We do the crisscross. We're going to slide this 2 down here and slide this 1 down there. So after the calcium, I'm going to need 1. And after the hydroxide, I'm going to need 2. It's important that my number goes outside the brackets. That means I have 2 groups of hydroxide. So we either reduce, or in this case, just simplify. We don't write the number 1 in chemistry. CaOH 2. That's calcium hydroxide, not changing the names. Here's a list of some common polyatomic ions. You'll notice that they have different amounts inside the brackets, and they come with different charges. But it's important that you never change anything inside the brackets. Sulfite, for example, is only sulfite if you see 1 sulfur and 3 oxygens. Its charge will always be -2. If you change the amount of oxygens, for example, change that to a 4, that's sulfate. So you can't change anything inside the brackets. Another thing that we want to watch that we don't want to ever see you do is if you found an example where, for example, I had 2 groups of hydroxide. You cannot factor that in. That's wrong. This is not the same as saying O2H2. That would be something completely different. Again, never change anything inside the brackets. So we're going to try these few together, and then I'll give you a few to try on your own. The symbol for sodium is Na. Carbonate, this H gives me a clue that it's polyatomic, is a CO3 grouping. The charge on sodium is +1, and on carbonate, -2. When we crisscross, keeping those little numbers outside the brackets, I'm going to have Na2CO3, 1. Now, and sometimes you'll notice that people keep the brackets in these cases, and other times you'll see them drop it. If there's only one group of carbonates, then it's okay to drop the brackets. Now, I recommend you always leave the brackets on, but if there's only one group of a polyatomic ion, it's technically okay to drop them. If you have more than one group, however, it's not. And you'll see some examples of that in this next example. Let's look at calcium and hydroxide. Calcium symbol is Ca, and its charge is +2. Hydroxide is a group. It is an OH group, and its charge is -1. When we crisscross, we're going to have Ca1, which we don't have to write, and I'm going to need 2 groups of the hydroxides. Remember, the number from the calcium goes after the hydroxide, and the number from the hydroxide goes after the calcium. In this case, if you drop the brackets, you would have a wrong answer. If you drop the brackets, it would look like CaOH2. It would look like 1 calcium, 1 oxygen, and 2 hydroxides. And that would be wrong. We don't want to do that. So this is where I recommend leave them on all the time. It's not technically wrong, and you won't make a mistake that way. Continuing along, calcium sulfate, Ca, charge +2, symbol for sulfate. It's an SO4 grouping, charge -2. When we crisscross, we're going to get Ca2 brackets, SO4, 2, and I can reduce this to CaSO4, calcium sulfate. Magnesium and phosphite. Magnesium, Mg +2. Phosphite is a PO3 group with a -3 charge. Crisscross. The 2 goes after the phosphite, the 3 goes after the magnesium. Mg3, PO3, 2. It's important that you watch name endings like ate and ite because they change the formula. So pay attention that you're copying down the correct polyatomic ion. What about if I've got a transition metal and a polyatomic ion? Well, this is the same as all the other cases. We're still going to write the formula for the iron as Fe. This Roman numeral tells me the charge will be +2. Nitrate is a grouping, NO3. Charge is -1. When I crisscross and put this 2 here and this 1 there, I end up with the formula Fe1, which I don't have to write, NO3, 2. This would be named iron 2 nitrate. Because iron is a transition metal, it still needs to have a Roman numeral. I know I'm going to have polyatomic ions in my name if I see more than 2 elements in the compound. Look at the formula for Na2SO4. I'll make it a little bigger for us to be able to see. This compound has sodiums, sulfurs, and oxygens. There are 3 different elements. When I have more than 2 different elements, I must have a polyatomic ion. My metal is named like any metal. Na is just sodium. The rest of this then must be a polyatomic ion, whether or not brackets have been included. Because SO4 is called sulfate, the name for this compound is sodium sulfate. In the case of FeOH2, I know that there are 3 different elements, irons, oxygens, and hydrogens. Fe is iron. OH is hydroxide. But iron is a transition metal, and transition metals must come with Roman numerals. checking your periodic table, we see that iron sometimes has a charge of +2 and sometimes has a charge of +3. I can see from the formula that I must have used iron with a charge of +2. So this name will be iron 2 hydroxide. How could I name the following polyatomic compounds? Well, LiCl has only 2 elements. There is no polyatomic ion there. Li is just lithium. Cl is chlorine, and I will change his ending to ide. When there's no polyatomic ion, when there's only 2 different kinds of elements, it's just first name, last name. Same with the next one. There's sodiums and fluorines. So, first name, last name. Na is sodium, and fluorine becomes fluoride. In the third example, we've got potassiums, oxygens, and hydrogens. There is more than 2 elements. Potassium is a metal. He gets the standard metal name of potassium. The OH grouping then will be a polyatomic ion, and if you check up here, you'll find out that its name is hydroxide. In the formula CaSO4, I see calciums, sulfurs, and oxygens. Calcium is a metal, and it'll get its regular name of calcium. The remainder of this compound must be a polyatomic ion. SO4 is sulfate, so his name is calcium sulfate. Finally, Fe2O3. Fe is a metal. His name is iron. Oxygen is a nonmetal. There's no polyatomic ion here, so we'll change his name to ide, oxide. But iron comes from the middle of the periodic table. It has to come with a Roman numeral. Again, I can see on my periodic tables that iron sometimes likes +2 as a charge and sometimes likes +3. Because oxygen has a -2 charge, the only iron that would make this proper formula would be iron whose charge was 3. So I'm going to call this iron 3 oxide. Hopefully this has helped you to name formulas involving polyatomic ions. The assignment following this set of notes in your workbook was there to help you practice with doing the names and formulas for compounds involving polyatomic ions. Although it is optional and you won't be tested on it in grade 10, I recommend that you try it anyway because compounds involving polyatomic ions are common throughout chemistry.